everyone. Happy Monday. Super excited for today's session because we have one house team today joining us. And you can ask a lot of questions about Lakehouse, about Apache Hudi, about Onehouse, about data and analytics to Kyle and Nadine on the Robert Show today. So we'll be discussing a lot about this as I can already see someone who's a LinkedIn user typing in hashtag one house. What you can all do is once you kind of jump into the show, you can always type in hashtag one house in the chat. And what we'll be doing is collecting all of these and also making sure that we're picking winners. There'll be two winners who win AirPods. So feel free to type in. I'm just checking if everything works. The entry does work. So feel free to type in. I see Sanjeev joining us. So we're live on LinkedIn, YouTube, Facebook, Twitter. I can see someone from YouTube joining us as well. So very cool. All right. So like I mentioned, obviously we'll be talking about the Lakehouse landscape, what's on the horizon for the Apache Hudi community, about Onehouse, and much more. So I'm very excited, and it's time for me to not make our guest wait, because I'm sure when we were talking backstage, they were pretty excited too. So let's get them up here. Hey Kyle, welcome to the Robert Show. Hey Nadine, welcome to the Robert Show.
Hey Robert, how are you?
All good. I am, like I was telling my audience, I'm super excited to learn about the Lakehouse landscape, about Apache Hudi community, where Nadine kind of, does a lot of things, and also about what Onehouse is up to. So, why not, for our audience, let's start with your introductions and then we can get deeper into all these topics.
Sounds good.
Awesome. So, Kyle or anyone?
Yeah, I'll get started. So hi everyone, I'm Nadine and I'm actually based in Seattle, Washington, along with Kyle. I've been at Onehouse for just about 5 months or so, focused on the open source side with Apache Hudi. And it's been an incredible ride. The community is growing really fast, anywhere from active GitHub contributions to people helping other people in the community with getting started on Hudi. Prior to Onehouse, I was at Rockset for almost 3 years, leading their developer initiatives.
Great.
Fantastic.
Thanks, Nadine.
Kyle?
I'm Kyle. I'm head of product at Onehouse. I've been in the data space about 10 years. I built several large-scale global data platforms, things for products like Office and Bing, if you know Bing's search engine, which is gaining a little bit more popularity now with ChatGPT going on in the mix. I was telling my friends maybe this will actually be an asset on my resume one day if it starts to get a little popularity lately. But I built several data platforms internally at Microsoft. Then I switched to building data products itself. And so I was in the Azure machine learning landscape, and I built some new features to get R and Python execution inside SQL Server, some fun stuff there. If people want to chat about the good old days that way. And then most recently, I was a product lead for Azure Databricks, and people probably know Databricks on the show. So I was a Microsoft employee, and we partnered with Databricks. We made an amazing product, Azure Databricks, and I was there from when it first launched up until about 1.5 years ago when I decided to jump ship and come to this brand new startup called Onehouse. So we're building in a similar space in the data lake and lakehouse kind of space, and trying to make data lakes easy, trying to make it super fast and convenient to pick a data lake architecture or lakehouse architecture and get started to go. So excited to be here with you, Robert.
Awesome. Pretty interesting backgrounds you both have, and I'm super excited about it. And I'm sure, Kyle, one day that might stand out in your resume, the Bing. So I'm looking forward to that as well. But since we are on this topic of data landscape, and who better than both of you here that I can ask this question about? We all have seen it evolving so much in the past 5 years or so. Obviously, from the conversations you've had with people in the landscape, what do you think? How are they rethinking their data infra? What are your thoughts? Nadine, maybe you want to go first?
Yeah. So One of the things is there's definitely a lack of developer experience and maturity with working specifically on data lakes. One of the things that comes to mind if you're a data engineer is probably Spark. And someone has if you're a data engineer, you've worked with it in one way or another. But you probably will want to be experienced with working with data frame manipulations, building and maintaining ETL pipelines. But let's say if you're able to do this, then you actually have to deploy and scale your Spark application in the cloud. And this is where you can get into errors and failures, and it can be hard to debug. And you'll definitely want to have some Spark expertise or hire someone who has Spark expertise to deploy systems or to deploy and maintain production systems. So one is the technology. The second challenge comes with performance and latency. So first off, I'm sure many of us are aware that data lakes store unstructured and structured data. But in order to make unstructured data queryable, you have to make it structured. So you want to create batch processes that could take anywhere from 30 minutes to hours in order for it to be queryable. This means that potentially your data application could be displaying stale data to your end users, and that's not too good, right? The other challenge with data lakes is you can actually have a lot of small files, which can impact query performance because the query engines will have to scan through the small files in order to return the results, and then you do something with the results. Finally, another challenge could be around or just in governance in general. Your data lakes can turn into data swamps, and I know that's a topic talked quite a bit in the data world because there's a lack of data organization and categorization, and this eventually can lead to some security and permission issues. But with all of these challenges, within the last few years or so, they're starting to have more products are entering the market. So it can be easier to work with data lakes. One of them is, for example, lakehouse, which provides like version control. Think of like Git for code, but Git for data. So you can use in your data lake whenever you need it. Another good project is Great Expectations. It's open source. It's a pluggable and open source tool that allows engineers to help assess their data quality by allowing you to write tests and review reports. So many more entering the scene with like Apache Airflow and Absolver. So with these technologies all of these technologies are centered around improving your experience with working with data or improving your experience with working with data in your data lakes.
Pretty interesting. Yeah.
I think a couple of trends that I'm excited for in the data lake space as well is, like Nadine said, the developer experience is poor. It's maturing. It's, if you look at Gartner and they project and they build these like hype cycle graphs and they talk about new technologies that are on the rise, and then as they fall into what they call the quote unquote trough of disillusionment. And then they go through this next phase where they get to maturity. And as Nadine called out, data lakes, they're actually, if you look at the Gartner hype cycles for 2022, I'm sure they're going to release new ones for 2023, but data lakes are squarely in the trough of disillusionment. And they're at the bottom of that trough. They're starting to come around the bend and turn. So people went through this whole hype cycle of data lakes when search engines were born, when these large scale systems needed a new path and a cheaper path than traditional data warehouses, which have been around for decades. But now in this trough of disillusionment, I'm excited, like Nadine called out a few examples, like new companies are all building in the data lake space and are working towards bringing data lakes out of that trough. And I think the emergence of the lakehouse architectural pattern is a big part of that, helping us push that path forward and make data lakes mature. Another piece that I think is interesting is looking at the convergence of streaming and batch data. Traditionally, people would have to choose between one or the other. Am I going to run large intervals of batch data processing, or am I going to pony up and pay expensive services and expensive compute to try to make my data really fast? And something that's exciting we can get into later about, with Apache Hudi and these other lakehouse kind of projects, especially Apache Hudi has like an incremental processing framework, and you can make the data process really fast and efficient, and you can combine these streaming and batch workloads throw away these old school Lambda architectures, and not have like divergence and forks in your systems and data silos around certain products that help you get faster batch or streaming workloads.
Yeah. No, I think.
Yeah.
Go ahead, please.
Oh no, I was going to say like another challenge with this is, you know, the role of the data warehouse. And the landscape,
exactly.
many people are reevaluating their data warehouse role in the data infra because of the explosions of cost. So many engineers are working with streaming sources like CDC to build their data applications, right? MongoDB has CDC. You can do Postgres, DynamoDB, etc. And if you're building like apps like recommendation or personalization, you'll want to probably incorporate some sort of streaming source. But if you send that streaming data to a data warehouse, you'll need to do like frequent updates. And what does this eventually lead to? Expensive merge operations. And this is the bulk of the costs, which will lead to high compute costs in data warehouses. And so this is, and the really interesting thing is when data warehouses were coming along, streaming sources or streaming data was not a thing. And so it wasn't really built to handle these use cases. The other thing with data warehouses is that they're immutable. Data is stored to disk permanently and all updates are append only. So you cannot rewrite over existing records. So if, you know, and so this is because data warehouses, again, were not designed to work with streaming data. But let's say if you have a data stream that's interrupted by, let's say, a loss of a signal, right? And it arrives late to the data warehouse. The warehouse will have to write the new data completely and then rewrite the existing data. So everything in disk is stored in the right time order. So that's another big cost too, right? So the thing is that the reason why data warehouses are so easy to work with is that they've been around longer and the maturity is there with data warehouses. But when you start maturing your data application or you start maturing your data infra or or your data application, right? You're going to want to incorporate a lot of data sources. You want to have a lot of diverse data sources like with streaming data and other things. And potentially you'll want to build different use cases for real time and potentially for batch, whatever the end goal for the company is. But specifically if you're working with streaming data, and if you're sending it all to the data warehouse, this is where the compute costs can shoot up. And if you're an engineer and you're building these systems, this is where you can start to feel the limitations of a data warehouse.
Interesting. Kyle, what do you think about, the vendors in the space, in other vertical silos? Anything that you can share?
Yeah, that's actually one of the motivations or core mission statements that we have here at Onehouse. So the world that I see today, most companies are building what I see as vertical optimized stacks, and they start with a compute framework, whether that's Apache Spark or Flink or Trino, Presto, these different compute frameworks, and then they build their data to be optimized, and they try to drive retention and dollars towards that compute framework. And so everywhere from the processing of that data down to how that data is stored and the multiple layers of optimizations of how to make that data more useful, more valuable, more fast and efficient. All these companies are motivated to keep you in one kind of ecosystem. With Onehouse specifically, we the product we're building, we can get into it later if folks want to chat, but we are building like a more horizontal layer. We're not building a compute engine here, and what we're trying to do is make it so that your data can be completely interoperable and useful from the query engine of your choice. So like if you have data locked up in RDBMS systems, event streams, other apps and services, you want to make use of that data, make it analytics ready. Onehouse can very easily take it from those type of sources to a data lake in well-formed tables. Apache Hudi is what we primarily rely on. We also announced one table which will interop that metadata between Delta Lake and Iceberg. If people are interested in these kind of projects, we can talk more.
Yeah.
And then your data is analytics ready for any of these engines. If you want to use Databricks, the best Spark experience. If you want to use Starburst with Trino, you want to use, Flink got acquired by Confluent, so maybe you're, Immerok, I should say, Immerok did. So maybe you want to use something like that as well. I think you had Seller Data on a show recently as well.
Yeah.
So, StarRock's Seller Data, they're working on Apache Hudi data sets as well. So great opportunities. I think it's about time to level the playing field across these and help people build future-proof data
Nice.
stacks.
Yeah, pretty interesting. Those were great insights, Kyle, Nadine. Thanks for sharing those. We have a few questions here and a few comments as well. Let's go out with comments first. One here from Sanjeev, and that's what you mentioned about one of the big challenge being a data engineer in selection of tool sets. Nowadays, we have so many options, and it's sometimes confusing which one to use. Have you come across such examples, Kyle? Any time where you have a customer sitting just there and asking you about so many tools out there, what to choose, or maybe just in general as well when you're having discussion with your data friends out there?
Oh yeah, it's the data landscape is evolving very fast, and there's so many new companies, so many tools, technologies emerging every day, every week. Check out the work from there's a first mark venture capital firm.
Yeah,
This guy
man.
named Matt Turk, right? He published the MAD 2023 data
Oh
landscape
my.
just a few weeks
Yeah.
ago, right? Oh, it's an explosion, man. And you see how it's evolved. I think he did a nice LinkedIn post where he showed something from like 2012 or something, right?
Right.
Versus 2023, and like how many companies are on the map. Luckily, Onehouse were on the map there. But yeah, there's so many tools and technologies. So Sanjeev, it's like I see this all the time. People just struggling just to make a choice of what to use. I've also seen like an interesting anecdote. I've seen someone that was moving from one pretty tight vendor ecosystem, and they were hoping to build on data lakes, but they were worried. They're like, hey, am I going from one pair of handcuffs to the next pair of handcuffs? Because
Yeah.
they're picking one big vendor versus the other big vendor, and they're like, what if I want to change again in the next 3 years? And like,
Yeah.
so it's a fast moving data ecosystem, and making those choices, it's important to pick things that will last longer than 3 years, so you don't have to be in this turmoil of data migrations so often.
Yeah, and it's still very difficult, I feel, where you can't have, like, it's ever evolving. Like with the Mad landscape itself, what Mad came out with, there are 1,400 plus vendors in there
Yeah,
in
it's
various
crazy.
ecosystems. So you can't decide, but the space is evolving very quickly, and definitely looking out for something which is long term, and the right product always works very well for all the enterprise level companies. We also have another one question here from Ayush from YouTube. So let's pick this one. How about cloud scale analytics? What are your thoughts there? Anyone? Nadine, Kyle, you want to talk a little
Yeah,
about that?
I feel like that's a broad question. I feel like I want to double click into this question. When you talk about cloud scale analytics, are you talking about scaling your application by yourself, or a serverless type of component to this? Maybe Kyle.
Yeah. If we get more details, Ayush, we can answer even better. But I would say, like, when I see this word cloud scale analytics, I'm thinking, being able to scale to any type of workload that you throw at it, whether this is like terabytes, petabytes, exabytes, cloud scale analytics, building like global scale applications. And yeah, those are where you need to make your smartest choices. And if you're building a data lake, if a data lake is in consideration, you should absolutely be considering a lakehouse type project like Apache Hudi. There's tons of use cases and stories. If you go to Apache Hudi's website, you'll see how people are using it and able to achieve some amazing results. Things like Uber, Walmart, Robinhood, TikTok, the folks at ByteDance built some of the largest data lakes on the planet using this, and certainly cloud scale analytics is achievable with these type of architectures.
Okay, pretty interesting. Since you spoke about Uber, Kyle, I have a question which is more around Uber itself. And can you tell us about, first of all, the hoodies creation and evolution, and also what challenge was Uber actually solving back then, and what were the obstacles which they were facing with their data infrastructure? So, Nadine, do you want to
Yeah.
talk more about it? Yeah.
Sure. So Hudi was born in 2016 at Uber to help with transactions and updates and with Uber rights, basically. So previously, Uber had an internal data lake that was using a Hive ACID framework. And in this framework, there was no incremental processing, no updates, and so on. So you will get an entire data back or data set back every 1 day or potentially every few hours. And you will have to compute the entire sync table, right? So you have to rerun the table. Back in 2015, this was pretty standard. So Uber fees heavy compute limitations and data freshness was in the 10 plus hours. And for Uber rides, this is not sustainable, right? We're so used to a different life around Uber, like all of our lives have adjusted since Uber. So Uber helped build Hudi to help bring the data freshness down from 10 plus hours to about 15 minutes or so. And it also brought level transactions and updates to the data lake. And this was just the start. From there was more and technical investments made to Hudi, and here we are today. So the thing with Uber is it faced these challenges because it had so much data to process early on. I think Uber and its data growth or data evolution was a lot faster than many companies back in 2015, right? So Uber was able to see these limitations early on and was able to adapt to it pretty early on. And this is how Hudi was designed to solve these things. So how do you bring transactional guarantees to the data lake? How can you effectively work with streaming sources where you can handle bursty writes and late arriving data? Again, Uber was dealing with this back in 2015, 2016. And these challenges is what inspired Hudi, and Vinod built Hudi. So yeah.
Okay. Yeah, those are pretty cool insights about how it was, how it has evolved, when was it created, and the other information that you gave, Nadine. So pretty interesting. One quick question I wanted to pick your also from our audience so we don't miss out, which is yeah, this question came in a bit early. How do you see the role of data engineering evolving in the context of a data stack and lakehouse architecture? Pretty interesting. Kyle.
I like this question. Very insightful, Aditi. And the data engineering role, how it might be evolving with the emergence of a lakehouse type architecture. I see that this is something to help make a data engineer's life easier. Someone like in an internal Onehouse Slack thread was asking a question. They're like, how did people build data lakes back in 2013, 2015? How did they build it before lakehouses existed, or this like architectural pattern? And it jogged my memory. I had to like go back because one of the first data lakes I built was in 2013 for Office, and it was when we modernized for the new Office web apps, mobile apps, and these kind of things. And that jogging back past memory lane, it was like, wow, we had hundreds of terabytes of data, all the click stream usage, every click you do, and mouse movement and error traces, all these things. We were collecting all this telemetry, hundreds of terabytes from users around the world, and we would dump the raw files into a data lake. And then we would have like hourly processing jobs that would recompute everything. And then every 24 hours, we would batch compute, recompute everything. And then we would compute it like the last 7-day windows all over again, recompute the entire frame because of late arriving data, merging updates, these kind of things. And so the amount of compute we used was incredible, and a lot of wastage of just reprocessing data just to be able to pull these things together. Because like I think Nadine called out, data lakes are immutable file stores. So previous to these lakehouse projects like Apache Hudi, you had to do this recompute. And now how to get to DT, your specific question, how that role of data engineering is changing is now you can treat data lakes like they are data warehouses. And you can apply merges, run delete statements. You can have, you can count on ACID transactional guarantees, and you're able to unlock, concurrency at the data lake scale. You don't have to worry about multiple writers, multiple readers coming into the same files, corrupting the data, taking down systems for like maintenance periods while you like reprocess or backfill some data set. None of that stuff has to exist anymore in the data lake. And so data engineers are now empowered to use the lakes more liberally, more freely, and without having to like understand all the 20 plus pitfalls that commonly happen on the lake.
Yeah.
I would like to also say, like, when you're talking about like there's all different types of stacks within your data infra, particularly with your analytical data stack. You want to have a separate data system to do that because of the concurrency, because of the compute resources. And so there's this idea of, it's kind of been there for the last 3 or 4 years, but now these best practices of building a separate analytical stack, which doesn't conflict with any transactional systems, is becoming a thing. Now within this analytical data stack, you have different systems coming into the space to handle different use cases. But in the case with the lakehouse, I call it the powerhouse because it can handle so much data, can process it and give you near real-time analytics within like a few minutes, like 5s of minutes. And be efficient in working with different diverse workloads, anywhere from the ingestions to the queryable side as well. So,
okay, yeah, I think that definitely answers for Aditi, and that's a very interesting question. It talks a lot about how things are changing, how things have changed, and that brings me to another question for you, Nadine, is around the role of Apache Hudi in building a modern data lakehouse. So, can you tell us more about that?
Yeah, so like I mentioned earlier, Uber had so much data early on, and it was able to adjust fast or make these switches within its data infra to handle, I don't know, terabytes, petabytes of data, a lot of data basically. But back in 2015 and 2016, there was no concept of a lakehouse. It didn't exist. I think Vinod was like, we need to have transactional guarantees on the data because we have so much data. I don't know. I should let Vinod talk more about that. But in the sense, like Uber definitely had a unique data journey that was a lot faster than a lot of companies. So now 5-6 years later, companies are facing similar challenges now with their data. And I think it's on par with what Uber faced. So they want faster data, potentially cheaper storage and compute, and they want to avoid things like data replication. And they also want to be able to work with a diverse set of technologies, like what Kyle mentioned, in the vertical and trying to avoid these vertical silos essentially. So a project like Hudi is unique in its sense that it can ingest, index, and process and manage data efficiently. From there, Hudi is not on the query side. You can integrate multiple query engines. There was a question about interoperability in the chat that I saw. So I'll put it in context here. With Hudi, you can integrate with Presto, or you can integrate with Trinio or other query engines to query the data that's in a Hudi table. In this sense, there's no silos. You can just integrate it. And I know we're working on building more support with different query engines, but there's a lot of query engines that are supported right now. And so this is why this is why lakehouses are the powerhouses in the data stack. Lakehouses like Hudi are meant to handle these heavy workloads and easily integrate with different technologies to avoid these vertical silos, but also power your data applications to provide fresh data to your end users.
Yeah, I think this is super interesting. Also, Nadine, just a follow-up question that I had was around also, since you mentioned so much about Apache Hudi, but how does Apache Hudi support the real-time and batch data processing, and what are some of the benefits of this approach? Like, I know you shared a bit about it, but have you had any, do you have any diagrams that you can show us, or anything that can give us more about insights around it would be helpful.
Yeah, if I can share my screen, I can just hop into the Hudi website.
Oh, very cool.
Let me go ahead. Let me go ahead and share my screen really quick.
While she gets it up there too, Ravid, if you're able to post the link in the chat, I bet that would help people too follow along.
I can't post in the chat, but I can share. But if you want to go to hudi.apache.org, you can see kind of everything there. And so with Hudi, you can ingest from all different sources. So if I go down, you have data streams, databases, cloud storage, and so on. And then you can get ASK guarantees. You can also once you ingest the data to a Hudi table, which is on top of some sort of data lake, you can build incremental pipelines, which is really important because you can query new data that's coming into the table without recomputing the whole table. You can also have different sorts of table services, which can schedule and orchestrate things like clustering, compaction, and more. And then you can also index your data as well for faster reads and writes. And then from there, as I mentioned earlier, you can integrate with popular query engines to query the data. Kyle, do you want to add more to this?
Yeah, I think you covered it pretty well here. Apache Hudi, like if you scroll down maybe to the features, like some of the core features that it's adding when you're integrating this whole ecosystem, but now you're getting mutable workloads. Apache Hudi has a whole bunch of services under the hood. You can think of it as like core, like database level features, things like indexing support, clustering, cleaning, compaction. Like all these advanced features you come to expect from a database or data warehouse, these all can run on Rails with Apache Hudi. That's another area where Hudi is uniquely differentiated to be more than just a table format. It's a full-fledged data platform where you can take these services and put them on Rails to run synchronously, asynchronously. There's so many different options to get the workloads done. But yeah, it's really an amazing project that can give you can unlock with these kind of things 10 100x performance improvements with how you write your data, read your data, incredible ways that you can the most common success stories I hear, especially from the big logos that I listed earlier, is also the ways that you can shrink down the latency of your data, people going from 24-hour batch processing windows down to like minute level latencies, which is an incredible value add for your data stack.
Yeah, I think one popular one customer, Kyle, you worked with was Apna. Yeah, so that was.
And that's one from Onehouse specifically. They shared a blog. That's a link that we could share with the folks as well. If you search for them, they shared a story about using Onehouse specifically, even beyond just Apache Hudi.
Oh wow!
But Ravit, that's a startup company in India. So if you have a lot of followers over there, probably some people will know about the company. And they talked about how they were able to move from some slower latencies and expensive compute to something that was pretty fast for them on Apache Hudi. So,
okay, pretty cool. Which company was this? Sorry, I missed it.
It's called Apna, APNA. Apna.
APNA. Yeah. Oh yes, yes. Okay, pretty cool. And what I've done for our audience is, those who want to check out the Hudi website as well, I have shared the link here. You can actually go and visit the Hudi website and learn more about it. And definitely, if you have questions, Nadine and Kyle are out there. You can always reach out to them on LinkedIn and ask more questions. Also, just a quick reminder for our audience. I know a lot of folks have joined us a little late, but are there. We're doing a very cool giveaway, 2 AirPods by Onehouse. So don't hesitate to type in hashtag Onehouse in the chat, and also please register for the event. So we have both the components out there, and then we'll be choosing a winner in a week, but feel free to type in. Also, Kyle, I had another question here around Delta Lake actually, and this was, how is Hudi different from other table formats like Delta Lake and Iceberg? So what are your thoughts there?
Yeah, thanks for the question. Yes, I mentioned I worked for Azure Databricks as a Microsoft employee and part of that Databricks Microsoft relationship, and was there from when we first launched Databricks. I was there when we first launched Delta Lake. when we first
Wow.
open sourced Delta Lake, and I've helped hundreds of customers modernize to this lakehouse kind of architecture with Delta Lake, and now I switched camps over to Apache Hudi as well. I've done a lot of research on the topic. Of course, it was a big move for me to leave such a great position to come to a brand new startup no one had ever heard of. We were in stealth mode even when I joined. So I've done a ton of research. I actually wrote this up in a blog. If I can share screen, I can just show you some of these. It would be helpful. Let me get to the tab here.
I like how you both have it so structured with yourself, even the blogs, and talk about, you know, the things that you've done, or you have everything show and tell, which is very cool.
Yes. And if you are able to paste this blog in the chat window, that's probably helpful for folks as well. Do you have it, or I can message it to you on the side?
Yeah, on the side, just put it in the private chat, and I'll just amplify it to our audience so they can learn more about it. Which is very cool.
And then people can read along while I show it on the screen. I'm not going to go through all the details here, but I'll just show you high level and then try to answer that question. Popular question people have in their mind if they're thinking about data lakes or lake houses. They probably heard of at least one of these three projects that are out there: Apache Hudi, Delta Lake, and Apache Iceberg. So Apache Hudi was born out of Uber with the Vinod Chandar, who created it, who is the founder CEO of our company Onehouse. Delta Lake, obviously, with Databricks. Apache Iceberg was born at Netflix. And yeah, they're three great, amazing projects. I think all three of them have really strong features and capabilities. I created a matrix table and broke them down piece by piece. You got Hudi, Delta Lake, Iceberg, and I've got links to all the docs. So I tried to make it, you know, as transparent as I could so people can go verify and validate all the information on their own as well. And what you'll see kind of standing out when you look at feature sets, Apache Hudi has a really rich set of features. I mentioned some of these around table services, especially these operations around cleaning, compaction, file sizing, index management. All these capabilities are either manual or non-existent in the other projects. And I saw plenty of people struggle to take care of these operations while they're running their data platforms. So for example, if you have streaming type workloads or near real-time workloads, and you're always writing to files or data sets, and then you want to cluster or like sort the data, you have to rewrite the data under the hood. And if you have a job that's trying to rewrite all the data at the same time as trying to like add some updates or change some data that's within there, you're going to have a lot of collisions, because most of these projects run on a concurrency model that's called OCC, optimistic concurrency control. And there it's kind of, you know, hope for the best, hope for no concurrency, hope for no collisions, right? But when you actually have an environment where collisions are kind of high, you're going to start to run into challenges. We have a whole separate blog just on concurrency and those aspects too, if people want to check out later. But yeah, you can read through this blog. It does a thorough comparison on the three projects, the different features, the ecosystem support. This is Hudi on the left, Delta Lake in the middle, Iceberg on the right. So you can see how comprehensive these are. When it comes to like engagement from the community, because these are all open source projects, anyone can jump into these projects, contribute, build with the community. Delta Lake has the most popularity, of course, driven by one of the largest data companies out there, Databricks. But Hudi and Iceberg are doing well also. When you look at engagement, like contributors, this was, I published this update in January, so these are December stats. You can see Apache Hudi, the number of authors here. It's certainly the project where a lot more people are like working together, and it's a diverse community.
Exactly.
Yeah, you can go through and look at this on your own time. There's details about feature, specific feature highlights, use cases. It talks about as well. And yeah, so I'll leave this for people to go read on their own time.
Yeah, I think there was a question about use cases too that I saw came in. So this would be a good start to look at, and if you want to look at some successful stories with Hudi and Onehouse.
Yeah, exactly. this would be, and what I've done for our audience is also I've shared the link with them. So anyone who wishes to learn more about it, want to look at the comparison, want to learn more about the features, benchmarks, learn about the community, this is the
Yeah.
place. So feel free to jump in, and I've shared the link here on YouTube and LinkedIn. So feel free to go ahead and if you have any suggestions, Kyle is out there. He's
Yeah.
always open to suggestions
Yeah.
and ideas. So feel free to go and suggest something.
And I
But
talk to a
we
lot of
while
people on this topic in the community. So like reach
exactly.
out to me if you have any questions. I've done the deep research on these areas, and I've also seen the inside story and hundreds of companies that have done their own research and have done their own
Exactly.
benchmarks, things that aren't publicly shared or exposed. I've seen all the research documents from those as well. And so I'm happy to share both my personal experience and what I've learned about these projects along the way.
Yeah, and you also might get some secret sauce from Kyle, so that's the incentive. So feel free to jump in. But Tammy here says she likes your work and will look
Oh,
into it.
thanks. Thanks, Tammy.
Kyle, all right. One quick question. Your interesting one from Karthik, and what he's asking is how Hudi is helpful in solving data quality issues. You want to take, Nadine?
Yeah, so for data quality on the Hudi side, when the data is ingested, I feel like a lot of that will have to be managed on the user side for data quality. Kyle, do you want to talk more about that?
Yeah, sure.
Yeah.
There's some cool features in Apache Hudi which can help in data quality. It's a broad question, right? But one that first comes to mind, if you go to Apache Hudi's website, search in the search bar for what's called pre-commit validators. There's actually this really cool framework that when you are writing data or ingesting data or committing data, there's this thing that we call pre-commit validation. And what it does is you can set an expectation of data or data quality, whether that is data meets it's within a certain range set, or it's not null, or like you can set expectations, you can customize the code, you can even write SQL on these pre-commit validators. And what happens then is as data is being written, it can be validated, then you can choose what to do if it doesn't meet that expectation, if you want to quarantine it or do something else with it. And what is actually really special about a lot of other, there's great data quality projects out there. I'm excited about the future of some of these that are building. Nadine mentioned Great Expectations, some others. But here, when you're writing data, you have the ability to run these validations row by row. And otherwise, if you're on the other side of the equation after it's written, then you have to do like table scans and like read the entire data set to do these checks and data quality validations. So you have some advantages of doing it like at the writer level and row by row kind of implementations, which is really great. You can catch individual rows before they're committed, and really efficient, fast ways to do it. So
awesome. All right, that's very helpful for Karthik, I'm sure. We have an open question. I might take that one, but before that, I wanted to ask. So now, getting to Onehouse, what are you guys building around the Apache Hudi? What's the project about? Can you tell us more about that? Because I'm sure now we've spoken about so many things about Apache Hudi, about data lakehouse, also about data engineering, how the companies, obviously about the Hudi's creation, how Uber has solved those problems, what were the challenges that they were facing. But now to getting to, Onehouse, I would love to learn more about what you guys are building there.
Yeah, this is great topic. I think the world that I've seen, and this is how Vinod, the founder CEO of Onehouse, and I first connected, was we went for a walk and we were chatting about the data landscape, and of course Hudi and Delta and these things we just talked about. But the thing that was most exciting to me about Onehouse and what we're building today is how to make data lakes easy and approachable. The way I kind of see it is, If you want to use a data warehouse, you pick it off the shelf, you turn the key, it's running, it's on, you use it, right? Write SQL. But what I've seen over the years and with countless enterprises and even startups is it's tough to build a data lake. People routinely take 3 to 6 engineers, 6 months to build a data lake. And the underlying data infrastructure, it crosses several different domains of technology, and you need specialized engineers to really build and operate like a production-ready data lake for your platform. And so Onehouse, we're taking these amazing features that Nadine and we just talked about of Apache Hudi, and we're automating these services and running them on Rails as like a cloud native SaaS application. So I'll share a screen even and just show you like our product page here. Let me share a screen. This might make it easier to have some visuals that go along with this.
Sounds good. Yeah.
Okay, so this first diagram looks really similar to maybe what you saw on the Apache Hudi website, right? Where you got the sources and destinations here. The idea is if you have data that's up in some streams, whether it's Kafka, Pulsar, whatever messaging bus you might have, or databases, RDBMS systems, or your data is already sitting in what you might feel is more of a data swamp, Onehouse can automatically ingest this data. We have features around continuous data ingestion, so you can have jobs where you don't have to think about compute. It's kind of like a serverless experience. You point to the sources, you tell it to read in this data, and now it's writing Hudi tables on your data lakes. And we will take care of, we'll automate all this data management and tedious chores around file sizing, partitioning, cleaning. While the data is ingesting, like if you have done one of these data ingestion projects yourself, if you're going from something like a database like a Postgres, usually the popular thing to do today is grab like a Debezium and a Kafka, and you expose like the change logs, the wall logs from Postgres, and then you bring them in, and then you write jobs that will like understand the changelog format and apply the updates, deal with the late arriving data. There's a lot of effort that goes into this, where here it's a point and click kind of system. We even have APIs where you can automate this like underlying infrastructure as a deployment, and you can define pipelines and run them. You can define low code style incremental ETLs. And at the end of the day, what we also do is once your data is written into Hudi tables on the lakes, then we sync it to the catalogs of your choice. By so doing, like say, for example, you're an AWS shop and you've got your Glue catalog handy, we'll sync all the data to your Glue catalog. And then any data analysts or data scientists, when they crack open, say, an Athena, or they crack open some other tool, they'll see the tables registered there in your catalog, and they can just start analyze, just like get SQL statements running on it. So we're trying to give this like plug and play experience, analytics ready data sets at your fingertips. So we'll sync this to even multiple catalogs. You want it to BigQuery, you want it to Data Hub, you name it. We just announced the project called One Table, where someone in the comments earlier was talking about like choice, right? And being like confused about the choice of which technology. This is certainly one of those where there's 3 really good open source projects, Hudi, Iceberg, and Delta, and people are stuck in this like choice analysis. And they're like, hey, but if I pick one, Snowflake, they love Iceberg, but Databricks loves Delta, or AWS loves Hudi, or, and it's like, okay, which do I choose? Because I might get, trapped one day on being one or the other. But with One Table, you can feel confident that like your data you write once, and then we'll interop this metadata across any of these layers, and you can unlock the best performance accelerations from Databricks and their Photon layers and extra caching, or even Snowflake with their recent developments with Iceberg native tables. You could take advantage of all these things with your data written once, centrally managed, and available to you. So I think it's a pretty cool experience, and ways where you can, instead of taking 3 to 6 engineers 6 months to a year to build, now you can do this in minutes. Point and click, your data platform is up and running. You don't have to worry about the on-call and maintenance of running these platforms.
Yeah. No, I think definitely, Kyle, there are so many options. You've kind of put it out there for the audience so many options, but at the same time, you've also narrowed it down that these are particularly time saving options that you can pick and do it in minutes. So pretty cool what you're building with Onehouse, and can't wait to see more progress in the coming few months. I know for a fact where you guys are already on the run. There's so much that how big is the Onehouse team, by the way?
Yeah, Onehouse. We just came out of stealth mode almost in February of last year. So like exactly a year ago, we came out of stealth mode. And at that time, we were a few people huddled around a desk, incubating out of a Greylock office in Menlo Park. Now we've doubled, tripled our team. We're up to about 30, is it right, Nadine? About 30.
25-ish to 30, somewhere around there. We're hiring, by the way.
Yeah, we're very engineering heavy. We're building our go-to-market team right now. So shout out if you're in sales, marketing, solutions engineering. We're still hiring engineering too. So we've got a lot of open roles on our onehouse.ai. You'll see like a careers page. Go follow and see if there's openings that look good to you. So
yeah, that's pretty cool. I think in at least in this time of the year, and even almost the last 6 months have been rough for a lot of people. So this is the opportunity you can definitely go check out and work with cool people like Kyle and Nadine. So that's a cool incentive. I know we know it very well. He's a very cool guy. So definitely I can vouch for Onehouse if you feel like working there. So there's one good question here from John that I wanted to pick. So how does pre-commit validation work with semantic interpretability? And so one app holds acronyms or codes and another holds equivalent expansion. Is there a mapping function in OD?
Let me grab the documentation page on this and see if it's helpful for the conversation.
Yeah.
Pre-commit. I am looking for pre-commit validators. If you find it faster than me, Nadine, let me know. Pre-commit validators. Here it was.
And this is the cool thing what I like about you guys, which is show and tell, bring on the references, bring it right for the audience. And that's very cool. So by the time, Kyle, you bring that up, a quick question for Nadine here that I wanted to bring up. Okay, you got it? All right.
Yes,
so
got it.
Let's bring this up for
John
here. Yep.
It's not a friendly documentation here. This is some code in GitHub. Hopefully I can help answer that question, John, about how does pre-commit validation work. This is in the Apache Hudi code base. You can go to client validator, pre-commit validation. And here you're able to come down and you'll see different types of classes where you can specify, like you'll get the data row set that will come in, and the row set then you can write either in like Java, Scala, or SQL statements that will validate the record. I think there's another function that I could look at. There's like examples inside the code base. If we had time, we could go search for and bring them up. But your question said, John, you said, so one app holds acronyms or codes and another holds equivalent expansions. Is there a mapping function in Hudi? So I don't exactly understand the full breadth of the question here, but what I would say is that you can define these commit validations via the different methods that I mentioned, and then you're able to, you can check those in to a Git DevOps kind of system if you want, and then you can attach these in your write statements. When you go to use Apache Hudi, you're thinking if you're using Spark, you might say something like Spark .write.format Hudi, and then you can add a dot options. You can specify the pre-commit validators inside the options configs, and then you're able to, as the data is being written row by row, run it against your validators. I don't know if that helped or if it was more confusing. Hopefully it did some good for you, John.
I would also say feel free to reach out on the Hudi Slack channel too, and we can
Amazing. Yeah, I've actually shared the Onehouse website here, onehouse.ai, and there, if you go below, you can also find the Slack. And Nadine and Kyle both are there. They are very responsive, so you can always reach out through Slack. It's much easier for a lot of folks. But Nadine, I was asking you one question about if folks want to learn more about Apache Hudi, where can they find some resources? One is the website for sure. So website should do the work, or do you have any other documents that they can learn from?
Yeah, I can share my screen really quick, and I can.
Sure.
Let me do that. Okay.
And Kyle, John says will do. So he got your stuff. Yeah.
Okay, great.
So if you want to join the community, there's a couple ways to get involved, but you can go to community syncs. When you go under community syncs, there's a button to join our Slack channel. I'm there, and there's a few PMC members and contributors there, committers there as well. We also hold weekly office hours and monthly community syncs. So a lot of people come in with their questions, and we have PMC members and committers that are there to help answer your questions as well.
Awesome. So this is pretty cool. Office hours, Slack channel, very responsive, very cool.
And we always wear two hats here at Onehouse. We have the open source hat and then the product hat as well. So in addition to finding us in the open source channels, if you want to just chat about product, you can go through our website. There's ways to get in contact us on the top through the try it free buttons, and you'll get in contact us that way too.
Awesome. This is pretty cool. I'm just checking if we have any other questions here for okay, one last question. Actually, I wanted to pick John's question here, and which is a very quick question. So based on what Kyle was explaining, interpretability is at the meta level. Yes.
Yes, and I'll show a diagram that makes this pretty easy too. Got it handy here. 100% share screen. Tab. This. Okay, yes, because this was in context of one table, if I remember right, John, the question that was coming. So there's a blog here from the website announcing one table you can read. There's this helpful diagram that's here. Let me see if I can zoom this if it makes it easier to see for the readers. Hopefully that's close enough.
Yeah.
What we do here, it's interoperability at the metadata layer, John. So your data is written once, and under the hood, like all three of these projects, it's Parquet files under the hood, right? And these Parquet files then have thin metadata layers for Apache Hudi, Delta, or Iceberg that describe how to access the data faster, more efficiently, do schema evolution. All these different features are run through the metadata. And so what we do with one table is, the specs are open for Delta and Iceberg, and we can interop that metadata to Delta metadata, which then can be leveraged by the native accelerations in Databricks, or the Hudi data can be represented as Iceberg metadata. So the end user, it's all the same data. It's not rewritten data, and the user will use a read client that doesn't know the difference, whether it's Delta, Hudi, or Iceberg, because the metadata is translated appropriately.
Awesome.
There is another question about schema on read or schema on write. Hudi out of the box supports schema on write.
Yep, and this is what I wanted to pick from Sanjeev. So I believe Hudi follows the schema on write rather than schema on read. Is that the right understanding?
Yeah, but then there's configs that you can adjust to have schema on read. So if you want to learn more about it and you're working with Hudi, reach out on the community Slack channel, and I can kind of tour guide you there.
Awesome. Sanjeev, you got it in. John found it very informative. So thanks for putting it out very well, Kyle and Nadine. And that also, I was enjoying this and I thoroughly enjoyed it. But keeping time in mind, definitely, Onehouse team, Apache Hudi, and you guys have such interesting insights. Kyle, Nadine, can't wait to host you back on the Ravit show. I'm sure I'll have a good chat with Vinod as well, and he might share about the early days too. So pretty interesting things that you're building up. Thanks once again for coming on the Ravit show, sharing such amazing insights about what you guys are building. And for our audience as well, you can reach out to them on Slack. You can go out on LinkedIn as well, and just put out a message to Nadine and Kyle, and they'll be happy to help you, give some information if you want to chat, and if you have ideas. And if you're looking to join them as well, so this is a good opportunity where they are hiring. So pretty cool stuff that Kyle and Nadine and the Onehouse team are doing. So give them a follow, and don't hesitate to reach out to them. Thank you once again, Kyle, Nadine.
Thank you.
Thank you.
Awesome. All right.